Hello, bachcho. Let's read this question. So the question says, the only electron in the hydrogen atom resides under ordinary conditions on the first orbit. When energy is supplied, the electron moves to higher energy orbit depending on the amount of energy absorbed. When this electron returns to any of the lower orbits, it emits energy. Lyman series is formed when the electron returns to the lowest orbit, while Balmer series is formed when the electron returns to the second orbit. Similarly, Paschen, Brackett and Pfund series are formed when electron returns to the third, fourth and fifth orbits from higher energy orbits respectively. Maximum number of lines produced when an electron jumps from nth level to ground level is equal to n multiplied by n minus 1 divided by 2. For example, in the case of n is equal to 4, the number of lines produced is 6, that is 4 to 3, 4 to 2, 4 to 1, 3 to 2, 3 to 1 and then 2 to 1. When an electron returns from N2 to N1 state, the number of lines in the spectrum will be equal to N2 minus N1 multiplied by N2 minus N1 plus 1 divided by 2. If the electron comes back from energy level having energy E2 to energy level having E1, then the difference may be expressed in terms of energy of photon as E2 minus E1 is equal to delta E, which is equal to, and the wavelength corresponding to this energy is hc divided by delta E. Since h and c are constants, delta E corresponds to the definite energy. Thus, each transition from one energy level to other energy level will produce a light of definite wavelength. This is actually observed as a line in the spectrum of hydrogen atom. Wave number of this line is given by the formula nu bar is equal to r multiplied by 1 by n1 square minus 1 by n2 square, where r is Rayberg's constant and the value of r is 1.1 multiplied by 10 raised to the power 7 meter inverse. So the energy of photon emitted corresponding to the transition n is equal to 3 to n is equal to 1 is, and the value of h is 6 multiplied by 10 raised to the power minus 34 joule second. So here the key concept is atomic spectrum. Atomic spectrum. So यहाँ पर हमारे पास जो इलेक्ट्रॉन ट्रांजिट कर रहा है उसकी एनर्जी कैलकुलेट करनी है. सो हमारे पास गिवन है फ्रॉम n इज इक्वल टू 3 टू n इज इक्वल टू 1. इस केस में हमें कैलकुलेट करना है energy difference or the energy of photon emitted. Now as we know, nu bar जो है that is the inverse of wavelength. So 1 by lambda is equal to nu bar, which is equal to r multiplied by 1 by n1 square minus 1 by n2 square. So यहाँ पर n1 जो है that is 1 and n2 is 3. n2 से n1 तक इलेक्ट्रॉन जा रही है and जो एनर्जी होगी as we saw that lambda is equal to hc divided by delta E. So delta E will be hc divided by lambda. Delta E will be equal to hc divided by lambda. So इसमें भी हम hc multiplied करेंगे. hc nu bar which is equal to hc multiplied by rh multiplied by 1 by n1 square minus 1 by n2 square. So यहाँ पर अगर हम values put करें then h की value है 6 multiplied by 10 raised to the power minus 34 joule second multiplied by c is 3 into 10 raised to the power 8 meter per second multiplied by r. r की value है 1.1 multiplied by 10 raised to the power 7 meter inverse. 1.1 into 10 raised to the power 7 meter inverse multiplied by 1 by n1 square. n1 square है 1, so 1 divided by 1 square minus 1 by n2 square which is 3, so 1 by 3 square. और इसके अगर हम वैल्यूज को मल्टीप्लाई करें then energy of photon is equal to 6 multiplied by 3 multiplied by 1.1 multiplied by 3 multiplied by 1.1 multiplied by ये जो within brackets जो value है 1 minus 1 by 3 square, that is 1 minus 1 by 9, 1 minus 1 divided by 9 multiplied by exponential terms को हम यहाँ पर represent करेंगे 10 raised to the power minus 34 multiplied by 10 raised to the power 8 multiplied by 10 raised to the power 7 and यहाँ पर 1 minus 1 by 9 जो है this is 8 by 9 and जो इसकी simplified value आएगी that is 1.76 multiplied by 10 raised to the power minus 18 joules. So this is the energy of photon emitted जो कि correctly given है option A में. So our correct answer is option number A. This is the required solution and I hope you understood the concept well. Best of luck.